view. A continuous function, when you graph it, you can draw a continuous line. You don't stop or start. You can do it in one motion. It's a smooth curve or line. No holes, no gaps, no jumps. That's continuous. When you graph a discrete function, you're only going to get points. You don't connect them. It's just points on a graph, like a scatter plot. So examples of continuous functions are things like growth, time, height. Money is often continuous if you count fractional parts of cents. Volume, the real numbers are continuous, and most of the functions that we will graph as continuous functions. Discrete functions is more real-world things like how many pets do you have, how many children do you have, anything that you can count with the natural numbers, like if it doesn't make any sense to include fractional parts in it. Integers, whole numbers, natural numbers, those are all discrete. Now, when you talk about the domain of a continuous function, we are going to use an inequality like greater than or equal. Or sometimes we'll just say that it's all real numbers. For example, a line, y equals mx plus b. Well, in this case, it's y equals 0.5x plus 1. There is no value that x cannot be. The domain is what are the possible x values. In the case of a linear function, it's all of them. It's all real numbers. But sometimes it doesn't make sense to include maybe the negatives, or maybe you're not allowed to have negatives. And in that case, your domain would be x is greater than 0. Or maybe x is greater than or equal to 0 if you could include 0. Sometimes your domain will be within a range, like maybe it'll be from -5 to 5, including those endpoints. So that's how continuous function domains are written. And remember, domain describes the x values. In a discrete function, for the domain, you just list the x values. So in this function, the domain would be 1, 4, 5, 7. They're right there. That's the domain. Now the range is based on the domain. So in our graph up here, we said that the domain can be any of these numbers. It's all real numbers. Look at the y-axis right here. The y-axis, there's points that are below it. The graph goes below the x-axis, so there's negative numbers. It goes above, so there's positive numbers. There's nothing that y cannot be either. So in this case, in this continuous function, the range would also be all real numbers. If you have a discrete graph, the range is the y values that you can get after you plug in those x values. There's a typo right here. This should say range. I'll fix it. When you see your worksheet, hopefully it won't say that.